Good evening to everyone. My name is Vasily and I am an engineer of Non-Engineering Department of Samar University. In my presentation today I am going to describe the field of interference suppression for GNSS receivers. I'll start by describing interference types, next I'll focus on interference mitigation techniques, and to finish off I'll consider the advantages and disadvantages of aforementioned techniques. Our entire life is about movement, and to move somewhere first we should know where we are. Imagine you had to go another city or even drive another city by car. How challenging travels without navigation systems would be. According to Navigation Market Evaluation, which was made in 8 International Navigation Forum, up to 2025 number of devices with GNSS receivers will grow up to 9 billion. With so widespread system, security challenges become a big concern because malicious distortion or damaging of position information may lead to a big disaster. At first, let's consider the types of interference attacks. The oldest and the most familiar type of deliberate interference is jamming. Jamming is using radio noise or signals in an attempt to disrupt communications. Transmitter tuned to the same frequency as opponent's receiving equipment and with the same type of modulation can, with enough power, override any signal at the receiver. Jamming may be effective for a short time, but main disadvantage of this sort of interference is overtness. Spoofing attack is more subtle and hidden type of interference. A GPS spoofing attack attempts to deceive a GPS receiver by broadcasting fake GPS signals, structured to resemble a set of normal GPS signals, or by rebroadcasting genuine signals captured elsewhere or at a different time. These spoofed signals may be modified in such a way as to cause the receiver to estimate its position to be somewhere other than where it actually is, or to be located where it is but at a different time, as determined by attacker. Spoofing attack is more complicated to perform, but is more dangerous because receiver may not understand that receiver signal is counterfeit. Next, I suggest to consider 4 main interference suppressing techniques. The first one is signal processing based, which exploits stages of GNSS receiver on the RF chain, for example, automatic gain control monitoring, as well as other common GPS stages such as acquisition, tracking, and/or navigation. Signal from some receiver stage processed by digital signal processor according to algorithm. As a result of the processing, we can suppress interference. The second one is cryptographic based, which attempt to provide encryption on GNSS signals, specifically on payload navigation data broadcasts from the satellites for additional layers of security and authentication. With cryptographic based technique, counterfeit or jamming signal will be rejected in authentication stage. The third one is correlation with other GNSS signals, which utilize additional constellations, frequency bands, and/or sensors to monitor and detect counterfeit signals on concurrent GNSS signals. If PVT solution for concurrent GNSS signals differs, it means that one of them is counterfeit. And the last one is antenna-based, which exploit multiple antenna techniques such as angle of arrival, to specially pinpoint the counterfeit signal sources for dissolution from authentic signals. Antenna array provides special lobe configuration which rejects suspectable directions of signal receiving. Aforementioned techniques allows us to suppress both jamming and spoofing attacks. This brings us to the final part of my presentation today: comparison of interference mitigation techniques. Signal processing based technique cost-effective, highly reconfigurable, and do not increase system complexity, weight and size because interference suppression performs by software of DSP. The main disadvantage is medium effectiveness because this technique constrained by quality of received signal. Cryptographic based technique provide good interference suppression, reconfigurability, and don't increase system weight and size, but make system more complex and thus more costly because this technique demands additional secure communication channel. The third one is correlation with other GNSS signals. This technique provides good interference suppression and reconfigurability. At the same time, it don't increase system complexity, weight and size, and thus cost effective. And the last one is antenna-based, which provide best interference suppression and don't increase system complexity. But this technique demands on special antenna array, which increase system weight and size, make system costly and not reconfigurable. We can see comparison of these techniques in the table. And as we can see, correlation with other GNSS signals is the most suitable. This brings to the end of my presentation today. We have realized that spoofing interference is the most dangerous type of interference. Next, we have shown that there is 4 widespread interference suppression techniques and compared advantages and disadvantages of them. The main conclusion we achieved, correlation with other GNSS signals technique is the most suitable for interference suppression. Thank you for your attention. I would like to thank Ilya Kudryavtsev, my research supervisor. I'll now be happy to answer your questions. For further discussion, feel free to contact me via email, mobile phone, or any messenger. Thank you.